I'm Claudia Diaz. I'm the Chief Scientist of NIM Technologies, and today I'll be talking about the protection of communications metadata and what NIM is doing about it. So first of all, what is communications metadata? So it refers to everything about communication that is not the content of what actually is being said. So this includes, for example, the origin of the communication, the destination, the time at which the information is sent, how much information is sent, and any detectable patterns in the timings and sizes of the packets being exchanged. So actually, communications metadata is exposed by default in all the internet protocols. So TCP/IP, HTTP, UDP, FTP, even secure protocols such as TLS or secure DNS that protect the content with end-to-end encryption, they still show the communications metadata of the origin, destination, timing, length, and so on. So this information is exposed, but to whom? Who can get it? So actually there is a number of entities that are intermediaries in the internet communications that are able to access this communications metadata. This includes from big players in the internet infrastructure, such as internet service providers, exchanges, autonomous systems, BGP routers, internet backbone participants. Generally, they can get access to a lot of communications metadata, but even small players such as whoever is running the Wi-Fi router or a local area network of somebody who's able to eavesdrop locally also gets access to the communications metadata. And of course, nation-state level adversaries such as the NSA have been known to collect metadata at a large scale and to analyze it in order to extract all kinds of intelligence. So there's more reasons why metadata is a very interesting type of data to collect and exploit. It is actually machine readable because it speaks the language of computers. It's basically language for computers to be able to route communications from their source to the destination in a proper manner. So it is machine readable, and that means that machines can make sense of it at a large scale very easily, as opposed to natural language, human language, which is much more difficult to interpret because maybe people are using words in a certain way or they have nuances, and this is a lot more harder to interpret. Metadata, on the other hand, is really easy. Also, it has a lot lower volume than the content. So if you think about a YouTube video, for example, it can be multiple gigabytes, the content itself, but the metadata would just include, what's the URL of this video, how many bytes it contains, and at what time it was watched. So it can be a lot less than the actual content, so it's also manageable in terms of sizing. And also, metadata has a lot lower protection than content. It's not lawful to just intercept people's communications and look into the content. This is protected by law. But metadata, because it's not considered quite as sensitive, it has a lot lower protection, so actually these many entities can lawfully collect this metadata and analyze it in order to obtain, to learn information about what people are doing on the internet. So is this a big deal? Is this a big deal, right? We can say, well, it's just metadata. As long as you don't know what I'm saying, should I really worry about you knowing like who I talk to and what time? So there is a few codes that show how metadata is actually considered as extremely valuable. The NSA General Counsel, Stuart Baker, said that metadata absolutely tells you everything about somebody's life. If you have enough metadata, you don't really need content. So this is how powerful it is in being able to understand what somebody's interested in, who their social network is, what their hobbies are, what their intentions are, what their interests are. You don't actually need to hear what they are saying. It's enough that you're able to observe all the metadata. And Diffie and Landau, in their book Privacy on the Line, they say that traffic analysis and not cryptanalysis is the backbone of communications intelligence. This is because you can collect it at large scale, you can analyze it at large scale, and it will give you all the big patterns, all the big picture that then allows you to zoom in order to break into the specific targets that you find most interesting, but you find them first with traffic analysis on the metadata. The traffic analysis of metadata can even be used to recover encrypted content without breaking cryptography. So let's assume we have perfect cryptography, no amount of cryptanalysis is able to break it, the secret keys are perfectly secret, we should have confidence that this content is protected and an adversary is not able to learn about this content. However, there are many situations where the traffic analysis of communications metadata can act as a side channel that reveals this encrypted content. So some examples are when you're browsing to a website with HTTPS, in principle, because the communication with this website is encrypted, somebody who's observing your communication, they cannot tell which specific page you're accessing in this website. So for example, if you're going to WebMD, check diseases, an observer, an eavesdropper would be able to see, okay, you're checking WebMD, medical information, but I cannot tell which specific disease you're looking for, right? However, the way to learn what somebody is doing in this scenario would be for an adversary to first download all these pages in the site and record for each page what is the pattern of packets that are seen on the communication line. So basically what number of packets goes in which direction, what are the sizes of these packets, what's the inter-packet period between one packet and the next. By doing this, you can build a fingerprint of each of these pages, such as when the target is downloading a page in the encrypted site, you're able to match the number of packets in each direction and the sizes in order to guess which specific web page they are looking at, even though the web page itself is encrypted and you shouldn't be able to learn this content. So this is obviously concerning, that even though we can have end-to-end encryption, we are very far from being done in terms of protecting the privacy of our communications. So if we wanted to have a wish list of what would a perfectly secure communication network offer, what are the properties that we want? So obviously we want to protect what a user is saying over this encrypted channel, and this already end-to-end encryption is a very important step to achieve that. But not only that, we also want to conceal who the user is communicating with. So what is the communication partner, from whom you're receiving packets or to whom you're sending packets, what's the location, so from where you're communicating, when and how long you're communicating, how many bytes of data you're exchanging, and any other patterns in the communication. And even you could go as far as to say that we want to conceal whether somebody's communicating at all or not. So these are all properties that anonymous communication systems aim to provide. And in the solution space, mixed nets are one of the best solutions that we have to provide these kind of properties.